Another one of my videos. This one is for Eureka Math, Engaged New York, Module 1, Lesson 5, Equivalent Ratios. We've been working on equivalent ratios for the last couple lessons. This one, we're just continuing on with our learning target that I can solve ratio problems by finding equivalent ratios. First, you'll be able to identify the ratio, identify the missing value, and then solving for that missing value by using equivalent ratios by either using the tape diagram or the giant one. In this lesson, we're going to concentrate on being able to solve problems that involve a total, which will be like problem example 1 on page 16, and then like exercise 2 and 3 on page 18, and then on the problem set, problems 1 and 2. The other ones on page 18, 1 and 4, and then on problem set 3 and 4, those involve a more, and we aren't going to really concentrate on those. We decided that those are more of what we call score 4. Those are above what we expect all students to be able to do. So we aren't going to really cover those, but if you get a chance, look at those. Those are good problems to work on. So let's go ahead and start looking at these. Let's go to the first problem here. So it's on page 16. So the county superintendent of highways is interested in the number of different types of vehicles that regularly travel within his county. In the month of August, a total of 192 registrations were purchased for passenger cars and pickup trucks in the local Department of Motor Vehicles. The DMV reported in the month of August that for every 5 passenger cars, there were 7 pickup trucks registered. So we have 5 passenger cars for 7 pickup trucks registered. And then our question is we want to answer is how many types of vehicles were registered for the county? Now, on the first thing they ask you on this, there's a problem A, and we're just going to kind of talk about this down below. It asks for how many different ratios can you come up with? And the easy one is, we can come up with 5 to 7, which is, of course, the passenger cars to pickup trucks. We could also do 7 to 5, which would be the pickups to passenger cars. And then we start thinking about what other, they say to come up with 4 different ones. And then you start thinking, what other ones can we come up with? The key is these are both part-to-part comparisons. The other ones we want to think about are the part-to-whole. And if we add these 2 parts together, we end up with 12, so we can come up with 2 other ones we could look at. And we could swap these around. We could get some other ones we could get, though, would be like 5, which is our passenger cars, to 12. So there we're looking at like part to whole, because there's 12 wholes in this ratio if we add those together. We could also do like 7 to 12 also. We could swap these around too and reverse the order if we want to do total to trucks. So these are, like I say, these are a part to whole versus a part to part comparison. We're going to be using that a lot. So a part to whole, part to whole. And that is very important because if we look up here, they're talking about a total with what we have, okay? B on this, they ask you to do part B, and the only ones we're going to really do is B and A, and then we're going to actually solve the problem. On B, they want us to draw a tape diagram to represent the situation. We're going to go ahead and do that, so let's go ahead and represent the cars. So we're going to represent that with a tape diagram. It's 5, so 1, 2, 3, 4, 5. So there's our tape diagram for the car. And for the trucks, that is 7. So 1, 2, 3, 4, 5, 6, 7. So there's our tape diagram for our trucks. Now, before we've always compared the number they've given us to one of these parts. But in this case, we have our total. So we're going to compare that. The total is made up out of both these. So instead of setting that total to one of these, we're going to set that total to both these. So both these are 192. So that means 192 is made up out of 12 parts. So that means to find out what each one of these parts is, we're going to take 192 and divide it by 12. And if we do that, we got 192 divide it by 12. That's going to go in there one time. 12, minus that down. We're going to get 7. Drop down our 2. And that's going to end up being 6. So we end up with is 72. So we're going to get 16 times. So that equals 16, which tells us each of these parts is 16. So to figure this one out, to figure out how many trucks would be, there's 7 pieces there, so it's 7 times 16. To figure the number of cars would be 5 times 16. And so we could work both out. That'd be 5 times 16. So we got 5 times 10 is 50. So 5 times 6 is 30. So that ended up being 80. And 7 times 16, 7 times 10 is 70. Plus 7 times 6 is 42. So we add those together. That'd be 112. And we end up with 80 and 112. Now you could also solve this problem by using one of your ratios that you created here that deals with the total, using the giant 1. So if we use that, if we did like our cars to the total, which would be 5 to 12, what do we need to times that by to equal something over 192? Well, we could see we already did the division, so we divide 192 by 12. We end up with our giant 1 of 16 over 16, and we would get 80 on top. And you could simply subtract 80 from 192 to figure out your 112 here. So you could figure it out either way, either using the giant 1 like we've done before or using the tape diagram. It works with these also. Let's go ahead and look at these couple other problems. So we're going to move on to page 18. We're going to go ahead and, so we have Sammy and David were selling water bottles, raise money for new football uniforms. Sammy sold 5 water bottles for every 3 water bottles that David sold. Together they sold 160 water bottles. So let's go ahead and work on this like we've done before. So we have, let's do a tape diagram for this one. So we have Sammy had 5, so 1, 2, 3, 4, so 1, 2, 3, 4, 5. Okay, so that's Sammy's. And David sold 3 for everything that David sold. If you think of these as maybe boxes that the water bottles came in, he sold 7 boxes, or he sold 5 boxes, he sold 3 boxes, but together they sold 160 water bottles. And you can think of that, well, those 160 water bottles came in how many boxes, which is our tape diagram. That might help you think through these. We ended up with 8, didn't we? So that means we got 160 divided by 8. So 160 divided by 8. So doesn't go into 1, so 8 goes into 16 twice. So subtract that down Bring our other 0 down. How many times does 8 go into 0? That's 0 times, so we end up with 20. So that's in each of those. We get 20 and 20. So this, Sammy would be 20 times 5, which is 100. So that's how many Sammy told. And Danny would be 20 times 3. So he sold 60. So that's how to use a tape diagram to figure that out. Okay, let's go on to the next one here. And we'll do it really quick. We'll go ahead and use our other one. So we have folding report card. You can read through this here. Pause it and read through it if you want to. And one folded, Mrs. Johnson folded the number of report cards, and Mrs. Stemsbull folded, the ratio was 2 to 3. So let's just go ahead on this one. We're going to set up a ratio. Let's just go ahead and set up one of them. So we have 2, 2. Let's do a 2 total. So this is Johnson to our total, which would be what? Just add the two ratios together. That gives us 5. What are we going to times that by to get to 300? So in order to figure that out, we got to take 300 and divide it by 5, which doesn't go into there. 3, so it goes into here. 6 times 30, minus that down. Bring another 0 down, so that ends up being 60, doesn't it? So that means our giant one here is 60 and 60. So 2 times 60 is 120. So he ends up being 120. And we could just simply subtract 120 from 300, which would give us 180 is what the other one sold. So that's how you can solve these using either a tape diagram or a giant one. You could use a tape diagram on this one too. I just wanted to show both methods. Good luck with these. Let me know if you have any questions. Have a good day. Bye.